Okay. So we'll start with, we finished with the physical, till the physical properties we finished. Okay. We'll start with the chemical properties. You just keep a paper and pen because you will write answers for a few questions. Anyway, it is there in the notes, but you just keep it. Okay. We finished the preparation part. We finished Williamson-Ether synthesis and we finished the dehydration, hydration rather. No, dehydration. Correct. Acidic dehydration of alcohols. Both we finished. Okay. Physical properties also we finished. They have low polarity. They will not have very high, very low melting and boiling point. And the initial members are soluble in water. The higher members are insoluble as the non-polar alkyl group increases. Okay. That much we finished. We'll start with the chemical properties. Lot of questions are there in the book back on chemical properties of ethers. Okay. Now, chemical properties. Now, here you have a bond like this in ethers. So, you have to cleave this bond. Okay. Either you can cleave this bond or this bond, which we will see that. Okay. And ethers are relatively inert. They do not undergo, because there is no reactive site in ethers. They do not undergo chemical reactions that easily. They don't want to undergo. Okay. But under drastic conditions, they will undergo. Like drastic condition means you will cleavage of this bond using hydrogen acids like HI or HBr. Normally they will give you HI only. HI or HBr, hydrogen acids, you will cleave this bond. This is very, very important reaction. I'll tell you how difficult they can ask this. Now, what happens? You have an ether like this, okay, and you cleave it with HI. What will happen is, you will get one alcohol, H with O, and one alkyl halide. You will get an alcohol, it gets cleaved here, H will go here, I will come here. The question is that which will go, H will go to this R or this R or R dash. That's the question that we will see. So, H will go to this, it will form one alcohol, one alkyl iodide. Okay. But if you have excess of the acid, this is with concentrated HI or HBr at high temperature, that is around 373 Kelvin, 100 degrees centigrade. So, this ROH will react with excess of HI. If you have excess of the acid, again it will give you one more molecule of the alkyl halide and water. So, overall reaction, if you have like ROR plus HI, you will get 2RI if it is the same molecule and water. Like this, this will be the overall reaction. Write down this reaction. Write down this reaction. Rough paper.
Auntie, the board is clear, Auntie.
Huh?
Auntie, the board is not clear. It's very blurred.
Oh my God, it's very clear actually. To see from here, it's very, very clear. Write down ROR dash. I'll send you the pic. You change R and R dash and write. Wait. I'll send you the pic. Okay. I've sent the pic. So, you change R and R dash. Okay. So, take it as CH3OC2H5 and write the reaction. Plus HI will give you CH3I plus C2H5OH. C2H5OH. Again, this C2H5OH will react with one more molecule of HI. One more molecule of HI forming C2H5I plus H2O. You are able to write, Krupa, Bharadwaj?
Yes, aunty.
It's easy. It's not very difficult at all. So you have ethyl methyl ether plus HI giving methyl iodide plus ethyl alcohol. Then ethyl alcohol plus HI giving ethyl iodide plus water. That's all. Now we will study the mechanism of this reaction to know which will form the alkyl iodide and which will form the alcohol. That is the thing. So now what happens in the first step? There are 3 steps in this. So first step, CH3O C2 CH2 CH3 I will write is there plus HI. Okay, first step, I will send you the pic. You just listen to me. CH3O CH2 CH3 plus HI. First what will happen? Because of the lone pair of electrons and oxygen, it will take off this proton. Protonation will happen. So you will have the oxonium ion. Ethyl methyl oxonium ion. Protonated ether. You will have the protonated ether plus I minus. This bond gets cleaved. Between HI, it gets cleaved. So you will get CH3, OCH2, CH3. Put plus charge and oxygen, H and I minus. It will happen only with HI and HBr because they are sufficiently acidic, and I minus or Br minus, they are very good nucleophiles. They are very good nucleophiles. That is why it will happen with HI or HBr. Now, in the second step, this is very important. In the second step, what happens? I minus will attack one of the alkyl groups. One of the alkyl groups. Now the question, which alkyl group? So here what happens? I minus, because of the steric hindrance, ethyl group is both are tetrahedral. Because of the steric hindrance, it will attack the lower alkyl group, primary alkyl group, lower primary alkyl group, and you will have a bond being formed between I and CH3, and the bond between CH3 and O gets cleaved. It gets cleaved, so you will have like this. You will have like this. This is the transition state. In the transition state, the bond between I minus and CH3 is being formed, and the bond between CH3 and O is being broken. You will have both partial bonds. So, after this, what will happen? After this gets broken, and you will get CH3I and CH3CH2OH. You will have like this. Okay. Now, so if you have used excess of the acid, the alcohol form will again react with one more same thing. You will get protonated alcohol plus I minus, and that protonated I minus will attack the protonated alcohol, and you will get, this will attack this, and you will get CH3, and this gets broken. I'll send you the pic, don't worry. CH2I and water. Now I will send you the pic. You just see that. I finished the mechanism. I'll repeat. Before that, if I send you the pic, you can understand it better. Okay. Now, what is happening in the mechanism? In the first step, ether is being protonated because it is a protonic acid. It gets protonated to form ethyl methyl oxonium ion. That is the protonated ether and I minus. This I minus, this is what is very important. This is SN2 mechanism. This is SN2 mechanism. If it is SN2, primary is favored, because in SN2 attack, that is breaking making, happens simultaneously. There is no formation of a carbocation. wherein you break, go, and then you will have a stable carbocation, which in turn this will attack the carbocation and forms. That will also happen when I will tell you. So the I minus will attack the smaller alkyl group, forming it will attack CH3I, and if it breaks, after breaking, this will form CH3I and CH3CH2OH. If you have used excess of the acid, then CH3CH2OH will react with HI, forming protonated alcohol plus I minus. I minus will again attack the CH2, forming CH3CH2I and water. Okay, this will be the mechanism. Write it down. Write it down, both of you. Over? Writing? Krupa, Bharadwaj?
Yes, Auntie, just a minute.
Write it. Write it. This is very important, very easy, and this is very interesting to learn actually. There are a lot of questions on this. Very interesting questions. Write it.
Auntie, have you sent this in WhatsApp, Auntie, now?
Yeah, I have sent it. I have sent the mechanism, except I had not written SN2 because it will go by SN2 mechanism. Okay? But just copy it. You will, if you write it once, you will register it thoroughly. That is why. Over? Over, ma? Bharadwaj?
Yes, Auntie.
Yes, Auntie.
Okay. Okay. So, and the order of reactivity of halogen acids is HI greater than HBr greater than HCl. HI is very good, then HBr, then HCl. Okay. So, this is the mechanism. Now, you keep the mechanism and we will try to analyze the reaction. So, if you have a reaction, see, if you have mixed ethers, if you have a mixed ether, question is which will form the alcohol and which will form the iodide. That is the question. This is what is the important question here. So, if you have two alkyl groups, the alkyl iodide form depends on the nature of the alkyl groups. If you have primary or secondary, remember always primary will form the alkyl halide. Always primary, secondary. If you have primary, that is the primary with lower number of carbon atoms will form, always will form the, that means less branching. Remember, those questions are also there in the in-text. Less branching will form the alkyl iodide. More branching will form the alcohol. Because it is easier to attack the less branching because of the stereochemistry, because of the arrangement. But there is a twist in the story here. Problem here is I cannot generalize this statement because if you have a tertiary ether, this is very important. If you have a tertiary ether like this, if you have a tertiary ether like this, if you treat it with HI, here what happens is that here HI, it is a good base also. Okay, it is a good base also. What happens is that here it will result in the formation of the carbocation. It will result in the formation of the carbocation, and what happens here is that you will get CH3OH over here. So what happens here is the HI will break the bond between this C and O, and this H will form methyl alcohol over here. Okay, that is the leaving group. That is a slow process. Okay, why it happens like that? Because here I will be a leaving group like this. Because why this happens? Because this tertiary carbocation is a very stable carbocation. Very stable. See, if you have a tertiary carbocation in the molecule. So, if you have a tertiary carbocation, it will form a stable carbocation because there are 3 methyl groups by inductive effect donating electrons. It is very stable. It is preferred to be forming. So, this will then react with I minus, forming the alkyl iodide, tertiary butyl iodide. So, this will be SN1 mechanism. SN1 mechanism, tertiary is favored. SN2 mechanism, primary is favored. Okay, so if you have a primary or a secondary, it is always the SN2 mechanism. If you have a tertiary, here is the twist. Children will get confused here. If you have tertiary, if you have, what happens is that if you remove CH3OH, it will result in the formation of a stable carbocation, which is a favored reaction. The departure of the leaving molecule CH3OH will result in the formation of a stable carbocation, so which is favored. This is a slow, this is the rate determining step, slow and rate determining step, and then this is attacked by I minus, forming the alkyl iodide. So they will give you different combinations, which will give you the alkyl iodide, which will give you the alcohol. Okay, that we will discuss. Okay, this is one thing. So if you have 2 alkyl groups, the lower one will form the alkyl iodide if you have primary or secondary. But if you have one of them is tertiary, that will form the alkyl iodide. Okay, because it results in the formation of a stable carbocation. Now, write down this reaction.
Auntie, can you send a picture?
Yeah, I'll send it. Actually, board is very clear, Krupa. Really clear.
Auntie, in the photo it is very clear, auntie, but in the video is not clear.
Yeah, that's what I'm feeling very bad actually. Okay, write down that. I've sent the pic. Write it down. Now you finish it off, then I'll tell you. There are very important points over here. I'll have to tell all that. So many questions are there. Even in the book back on ethers, especially this part, many questions are there. Over, ma? Over, Bharadwaj, Krupa?
Yes, Auntie.
Okay.
Yes, auntie.
Now you can also have alkyl aryl ethers. What will happen to alkyl aryl ethers? What will be the reaction? So if you have alkyl aryl ether like anisole or phenitone, CH3 or C2H5, what will happen is invariably the bond between R and O will break, because I cannot break this bond. Why I cannot break the bond between benzene, carbon and oxygen? Why I cannot break that? Why I cannot break that bond? Is it easier to break this bond? Because the pair of electrons and oxygen is involved in resonance with the ring. It will have a partial double bond character. sp2 hybridized carbon will have a shorter and stronger bond. It is difficult to break this bond. So you can break this bond. So when you break this bond, I will go here and H will go here. So you will have, always remember, you will get phenol and the alkyl iodide. You will always get the first step is the protonation. Same thing as you can write that actually. You will have the protonation. Then this protonated molecule is attacked by that, forming the phenol and iodide. And like other alkyl, general alkyl iodide, this will not undergo further substitution to form the aryl iodide like chlorobenzene or iodobenzene, because this bond cannot be, for that you need to break this bond, benzene and oxygen bond, which is not possible. It will not undergo nucleophilic substitution easily. So you cannot break this bond and the reaction will end here. It won't react with another molecule forming the alkyl iodide. Okay. So if you have alkyl aryl ethers, that is, you have a ether between alkyl and aryl, you always remember, always end up with phenol and the alkyl iodide. You have to mark that answer. Always end up with phenol and alkyl iodide. This is one. Second point, if you have an ararkyl, ararkyl means what? Like benzyl alkyl ethers. Ararkyl means benzyl alkyl ethers. Reverse will happen. Here, like our tertiary, you are going to get a stable benzyl carbocation that will form the iodide and this will form the alcohol. So you here in ethers, especially the cleavage part, you have to be very careful which is the reactant. Primary, secondary, that will form the iodide. But if it is tertiary, tertiary will form the iodide. Okay, the smaller will form the alcohol then. Then if it is aryl alkyl ethers, always you get phenol and the other one will form the iodide, alkyl group. But if it is benzyl, that is ararkyl ethers, ararkyl and alkyl ethers, then you always get benzyl iodide and the other will form the alcohol, because this results in a stable benzyl carbocation, which is very, so you know that anything linked with ring plus or minus charge, it is shared by all the 6 members of the ring. So that is why it will be very stable. So you have to remember this. All the 4 react differently. So I'll send you the pic of this. You write down this also. Okay, you write down this, then we will do the exercises. There is one example question. We will do the exercises. You keep the textbook, both of you. Keep the textbook. You write it down, then we will keep the textbook, then we will do.
Auntie, what's the page number, Auntie?
Page number, I'll just see. Since the board is not very clear, it is easier to copy from the book. This we finished. 11.6 we finished. 11.7. In my book, it is 341 Bharadwaj. 341. Maybe around that. 1 or 2 pages this side, that side. Got it?
And it's in page 349.
3, 4?
49.
349 Bharadwaj.
Yes, auntie, got it.
Got it. Now, see the question there. Give the major products that are formed by heating each of the following ethers with HI. So, what you have to do, if it is, see one thing, if it is tertiary, that will form the iodide. Otherwise, the smaller will form the iodide. So, based on that, you answer. So, both of you will answer on rotation. So, I will just write it. Okay. First is, write down the reactant. CH3, CH2, CH3, CH2, O, CH2, CH3. Krupa, first one. You are treating this with HI. Tell me the product form.
And it will be CH3, CH2, CH3, CH2. Instead of O, it will be OH.
Very good.
Plus,
That is what I wanted. So, primary will form this is secondary and this is primary. Primary will form the iodide and the secondary will form the alcohol. Very good. Very good. Okay. Second one. Bharadwaj, you will answer this. CH3, CH3, CH2, O, C, CH3, CH3, CH2, CH3. You are treating this with HI.
And it will be CH3, CH2, CH2. Then instead of O will be OH. Then plus CH3, CH2. Then C and 2 CH3s, auntie, plus I.
Correct. Why it is happening like that? Why it is happening?
The bond gets broken.
This is happening because this part is tertiary. This is a tertiary carbon. This is a
Yes, sir.
tertiary carbon. So it will form the alkyl iodide. Okay. Now, third question. Third question, you will have benzyl phenyl ether. Now tell me which will form the alkyl iodide and which will form the alcohol.
the one with CH2 will form iodide.
No. Iodide, yes. Correct. One with CH2 will form iodide. Always you will get here phenol. One of the product will be phenol. Very good. Because it is difficult to break this bond. So you will get this. Very good. You have understood now. Okay. So this is the example. Lot of questions are there on this. You will do in the book back also. It is there. Okay. So actually in apart from electrophilic substitution, only one reaction is there, ether. But that itself is in detail. You have to learn thoroughly how it is broken. Now, being the aromatic aryl alkyl ethers, being having the benzene ring, they will undergo electrophilic substitution. What is electrophilic substitution? Hydrogen of the benzene ring directly substituted, you call it as electrophilic substitution. So they will undergo electrophilic substitution, and you know that the group already present will direct the incoming group to the different positions. So here you have the alkoxy group already present in the molecule that will affect, it depends on whether it activates or deactivates. If it is plus R effect, it will activate. If it is minus R effect, deactivate. Activating means it will increase the electron density on benzene. It will activate towards electrophilic substitution. Then it will be orthopara orienting, orthopara directing. If it is deactivating, it will be meta-directing. And I keep telling this, meta-directing will be all the carbonyl, nitro, CN, all that they are minus R. Others are all plus R. So what happened? Here write the resonance structures. Pair of electrons are involved in the ring. It is plus R effect. So how will it move? Write the resonance structures. I will write it on the board, you write it. Write the resonance structures. Over? Finished?
Yes, aunty.
Okay. Now we will study the electrophilic substitution reactions. First, we will study the halogenation. Halogenation. For halogenation, normally you will need a Lewis acid catalyst, but here because of the plus R effect, you don't even need a Lewis acid like FeCl3 or iron or FeCl3. You just take benzene in acetic acid, bromine in acetic acid. What are the products formed? You will get orthobromo. If you take here, you take here CH3 only. Take anisole only. It's easier to name. Orthobromoanisole and parabromoanisole. Orthobromoanisole and parabromoanisole. What will be the IUPAC name? 2-bromo 1-methoxy benzene or 4-bromo 1-methoxy benzene. 2-bromo 1-methoxy benzene or 1-bromo 4-bromo 1-methoxy benzene or 2-bromo 1-methoxy benzene. You will have the compounds. So here which will be the major product? Because bromine is also a bigger atom, and methoxy is also a bigger group. Ortho product is not a major product. There will be steric hindrance. This will be minor product and the para product will be the major product. Para product will be the major product. So, it is write down the names, orthobromoanisole, parabromoanisole or 2-bromo 1-methoxybenzene or 4-bromo 1-methoxybenzene. So, it will undergo halogenation at ortho and para positions. Write the reactions. See, if you are here only, no, I would have made you people to write on the board. If you write on the board once, you will learn it properly. You will never forget. Okay, over?
Done, aunty.
Done,
Aunty,
aunty.
we have only 2 more reactions now, aunty.
Yes. Yes. So, now we will do Friedel-Crafts reaction. Friedel-Crafts means you will have anhydrous AlCl3 catalyst. Always remember. Friedel-Crafts means anhydrous AlCl3 catalyst. So, here you can have Friedel-Crafts alkylation or Friedel-Crafts acylation. So, you treat it with CH3Cl, anhydrous AlCl3 with a low polar solvent like carbon disulfide. You are going to get, write the reaction, write the products. You will have 2-methoxytoluene or 4-methoxytoluene or what will be the name? 2-methoxy, no, which will come first? Methoxy, methyl. So, meth is common, next is O and for here it is Y. So, that will come first. So, 1-methoxy, 2-methylbenzene, 1-methoxy, 4-methylbenzene. 1-methoxy, 2-methylbenzene or 1-methoxy, 4-methylbenzene or orthomethoxytoluene and paramethoxytoluene. You can write that. So, which will be the major product?
2-methoxytoluene will be a major product.
Major will be para product. Here also steric hindrance will be there. So 4-methoxytoluene will be the major product. Write it with acyl group. What is acyl group? Acid like acetyl chloride. It can be aliphatic or aromatic. We will just write it with aliphatic, CH3COCl. So, you are going to get anhydrous AlCl3. Here also, actually here more steric hindrance will be there. You will definitely get the para as the major product. Ortho will be to a very, very small extent. See, here this compound without OCH3 it is acetophenone. This compound is acetophenone. So, it will be a derivative of acetophenone. This will be 4-methoxyacetophenone, 2-methoxyacetophenone. And definitely, para will be the major product. If they ask you which will be the major product, you will have to write the para product. Very is my... Even in September, it is so hot here. I don't know. Sweating a lot. So, Krupa, Bharadwaj, if they give you C6H5 here, you have to write C6H5 here instead of CH3. That will be the derivative of benzophenone. Instead of acetophenone, it will be the derivative of benzophenone. So, based on that, you will have to change. Write it with C6H5COCl also. Write the reaction with C6H5Cl. You are able to see the board, or shall I send the pic?
It's somewhat clear.
Somewhat. So I will send you the pic. You copy that and then write it with C6H5COCl.
And in the place of CH3COCl, we have to write that 20.
Instead of CH3, you will write C6 CH3COCl. You write C6H5COCl. Benzoyl chloride. This is
Okay.
chloride. Benzoyl chloride. Write the reaction.
Yes, Auntie. So instead of CH3CO, it will be C6H5CO.
Yes. C6H5COCl. So this H and this Cl will go. So this carbon will get linked to this carbon. Here also it is the same thing. You will remove this HCl and this carbon will get linked to this. Over? Finished, Krupa Bharadwaj?
Yes, Auntie.
Okay. Now the last reaction, nitration. Nitration. So you treat it with nitrating mixture. Take anisole. Treat it with nitrating mixture. That is concentrate the reaction. Concentrated nitric acid plus concentrated sulfuric acid. You are going to get, what are the products formed? Orthonitroanisole and para-nitroanisole. Here also para will be the major product. Para will be the major product. 1-methoxy, 2-nitro, MN. So M will come first. So 1-methoxy 2-nitrobenzene, 1-methoxy 4-nitrobenzene. Write the reaction. What happened to Bharadwaj? Krupa over, ma?
Yes, Aunty.
Bharat also went off. So we'll do in text, Krupa. Take the page. I don't know the page. I'll tell you in my book. It is 342. Next page. So we'll do all the in text. I'll send you the pic. You just write it in rough sheet. I'll send you the pic. You finish it off. Finish off the notes. Okay? You won't be answering.
Yes, Aunty.
Good. You will learn it well. No problem. So, first one, write the reactions of Williamson synthesis of 2-ethoxy 3-methyl pentane starting from ethanol and 3-methyl pentane 2-ol. First thing, you write the reactants. First, you write the ether to be formed. 2-ethoxy 3-methyl pentane. First, you write pentane. Oh, Abhik also joined.
And he called me, and so I called. Gmeet call got cut and by mistake.
Ayyo. So,
He called
you
me to
missed
inform
Abhik.
me.
You are very late today.
No, and actually it was raining over here, so it was like current was completely off. And
Important it was ether cleavage. It was very important. Okay, we are right anyway learning the in-text questions. We will learn that properly. Now, take a rough sheet and start writing Abhik. Write the reaction synthesis of 2-ethoxy 3-methyl pentane starting from 3-methyl pentane 2-ol. So, first we will write 2-ethoxy 3-methyl pentane. 1, 2, 3, 4, 5. Okay. 2-ethoxy. That means I will do it like this. This will be easier for me. 2-ethoxy. Okay. 1, 2, 3. 3-methyl pentane. So, it will be CH3, CH2, CH, CH3, then C, CH3, O, C2, H5. Now 1, 2, 3, 4, 5. 2-ethoxy, 1, 2, correct.
Andy, can you repeat the question, Andy?
I repeat. Write the reactions of Williamson synthesis of 2-ethoxy 3-methyl pentane. 2-ethoxy 3-methyl pentane. First you have to write that compound first. Then only we can prepare that. So first we will write 2-ethoxy 3-methyl pentane. Write that first. First you write pentane. Then put on the second carbon atom 2-ethoxy, ethoxy group, and third carbon atom you write methyl. You will have this compound now. Now, how do you prepare ether using Williamson synthesis? You should one have alkyl halide, the other you will have sodium alkoxide. Okay, so if you put R and R dash, one will be an alkyl halide, the other will be an alkoxide, sodium alkoxide. So here you have to decide which will be the alkyl halide, which will be the alkoxide. Okay, so we know that it proceeds by SN2. Williamson's is an SN2 mechanism. You always prefer primary alkyl halide. Smaller group will form the alkyl halide. So they have mentioned both the starting compounds. One is ethyl alcohol. Second one is 3-methyl pentan 2-ol. 3-methyl pentan 2-ol. 3-methyl pentan 2-ol. So, starting from these two compounds, you have to prepare this compound. So, one of them you have to prepare alkyl halide. Other one you have to prepare alkoxide. You have to decide which one. So, which will form the alkyl halide? Which will form the alkyl halide? Krupa, Bharadwaj, Apik, which will form the alkyl halide? The smaller group will form the alkyl halide. So, which is smaller here?
Ethanol.
Ethanol. So, ethanol will form the alkyl halide and 3-methyl-2-pentanol will form the alkoxide. How do I prepare? You know that alcohols react with sodium metal forming the alkoxide. This you will do it in the lab also. Ethanol plus sodium will give you sodium methoxide. Same way 3-methyl-pentan-2-ol plus sodium will give you 3-methyl-2-pentanoxide. So treat this. First you write C2H5, treat it with HBr. Treat it with HBr, you will get C2H5Br plus water. First reaction, C2H5OH plus HBr or on the arrow HBr, you will get C2H5Br plus water. Then you take 3-methyl-pentan-2-ol, treat it with sodium, you will get 3 2
Auntie, will we get sodium 3-methyl pentane 2 oxide?
yeah, sodium 3-methyl-2-pentanoxide you will get. Then what you do? You treat both these. That is, ethyl bromide will react with this, will forming your product. This is very, very important. Like, however they give you the product, you will have to get it from the proper alkyl halide and proper alkoxide.
Auntie, after getting sodium 3-methyl pentane 2 oxide, auntie, what you have to do the last one, auntie?
Last will be treat ethyl bromide with this sodium alkoxide. And you will
Okay,
get the
okay.
product.
Okay, okay.
Treat both and write the reaction. Please answer. I will finish off ethers now. Please answer the entire book back. Alcohol, phenols, ethers. Very, very interesting questions are there. But easier than haloalkanes and haloarenes, definitely. So answer that. We'll discuss. Okay? Finished?
Yes, auntie.
Okay. Now, second question. What is the second question? Which of the following is an appropriate set of reactants for the preparation of 1-methoxy-4-nitrobenzene? So, you are going to prepare 1-methoxy-4-nitrobenzene. This is our product. So, set of reactants given is, you will have this is the alkyl halide and this is sodium alkoxide, or you will have this alkoxide and CH3Br. So now tell me which set of reactants will give me this. Same thing, Williamson-Zeta synthesis only. So which is favored in Williamson-Zeta synthesis? Which all?
The smaller group.
Huh? Which is
Auntie, actually, what we should get, Auntie?
Williamson's ether synthesis. Which alkyl halide is favored? Just now I told.
Primary halides, auntie.
Primary alkyl halide is favored. Why? Why primary alkyl?
Because the reaction occurs when SN2 is
Very good. Reaction occurs by SN2. SN2 primary alkyl halide, SN1 tertiary alkyl halide. So, which will be a proper set of reactants to form this ether? Where is the smallest alkyl halide?
second one.
Second one.
Second one. Very good. This is the primary. You have methyl bromide. So you have a smaller alkyl halide here. Whereas this is not a smaller alkyl halide. So this will give me the proper product. Because of SN2. Okay. Next, third question. Predict the products of the following reactions. Predict the products of the following reactions. I will write the reaction. First one. Abhik, you learn it now itself because we learned this in detail. Actually,
Okay.
we learned this in detail.
Okay.
Okay, what is the product formed in the first reaction? Here, see, whenever you treat an ether with HIRH, only HI or HBr will cleave the bond. So, either you can break this bond or this bond. This is also by SN2. So, always the cleavage will break the bond between this, you will break this bond. So, it will break this bond. Always you will get the smaller alkyl halide and the bigger will form the alcohol.
Auntie, once again, can you tell which bond should be broken, auntie?
So, you should break this bond. Because it is SN2. Because it is SN2, you will break the bond. You will get the smaller alkyl group. Smaller alkyl with the alkyl halide. So, the larger will form the alcohol and the smaller will form the alkyl halide because it is SN2. But if it is tertiary, it will be the reverse. It will be SN1 and tertiary will form the alkyl halide. Remember. Okay?
Okay.
Tertiary will form the alkyl halide. Second reaction.
Auntie, will it not be CH3Br?
Oh, sorry. Oh, I was writing that I only know and that mechanism I was. Sorry. It is CH3Br. Now you have C6H5O, C2H5. What is the name of this compound? Common name? What is the common name of this compound? Phenetol. Remember, with CH3 it is anisole. With C2H5OH it is phenetol. You have to know this. They will give you as phenetol only. That is ethyl phenyl ether. So when you break this, which will form? You will definitely get, if it is an aryl alkyl ether, one is always the phenol. One is always the phenol, other you get the alkyl halide. So here, what are the products formed here?
Auntie, we'll get C2H5Br, auntie, for the...
And phenol.
And
Phenol, auntie.
Phenol.
correct. C2H5Br and phenol. If it is R-arkyl, then you will get the R-arkyl halide and the other will form the alcohol because R-arkyl carbocation is stable. tertiary you have a group, it will form the alkyl halide. RRKL you have a group that will form the alkyl halide, because both tertiary carbocation and RRKL carbocation are very stable and it will go by SN1. Third, same reactant, you are doing nitration. Concentrated HNO3, concentrated H2SO4. Phenitol only. What are the products formed? Abic. We learned this also. It will methoxy group is plus R effect. Okay.
Okay, auntie.
It will donate electrons. It will activate. When it activates, it's orthopara directing.
Okay.
Orthopara directing substituted product in electrophilic substitution. So you will have orthonitrophenitol and paranitrophenitol. You will have orthonitrophenitol and paranitrophenitol. Now, the last one, you have the tertiary. CH3 thrice C OC2H5. Now, when you cleave this, what will happen when you cleave this? What will happen when you cleave this? Which will form the alkyl halide, which will form the alcohol?
And it will form ethanol, auntie.
Correct. Here, because it is tertiary will form the iodide, because it will go by SN1. Smaller will form the alcohol. Tertiary carbocations are very stable. That is why it will form SN1. Okay. So, this completes alcohols, phenols and ethers. We have finished everything. Have I sent the notes completely till the last class? I have to check it up.
Auntie, did you record today's class, auntie?
Yeah, I have recorded today's class.
Can you send the recording along, auntie?
Because
I'll
internet
go through.
was breaking. Actually, Krupa was only present throughout.
Okay.
No, even Bharadwaj was like, I had problem.
Even in this little rain also, they're like fully cutting the power over here. Auntie.
Yeah. In Chennai, even with little rain, you will lose it. So, did I give the nomenclature and preparation of ethers? Williamson's, have I sent the notes? Have I sent the notes? Preparation?
I don't think so, auntie.
Huh?
I don't think so.
That's why I have a doubt. I will have to check it up. Then I will send the ether notes completely.
Auntie, this time we have this alcohols chapter for like our exam, auntie. So it will basically be MCQ type. So what kind of questions they might ask, auntie, in MCQ type?
MCQs. They will ask you that fill in the blanks, conversions, all conversions. Okay. So they can ask you like this cleavage, only alcohols, is it, or alcohols, phenols, ethers?
And the alcohols,
phenols,
phenols and this thing, as well as P block, auntie. You have 2 chapters.
Alcohols, phenols, ethers complete is there?
Yes, auntie.
Okay. I told you, no, arranging in the increasing, decreasing order, boiling point, all that.
Okay.
Okay. So, you first answer book back, because one more questions many can and you can answer exemplar also. I will discuss it. I will discuss after I complete biomolecules. because I'm worried about the completing the portions, man. I want to first complete the portions. Organic, when I sent the last this one, I am just searching. Wait. I have to delete so many this one. This is yeah, this is last organic what I have sent. Ethers I have sent till IUPAC system. That's all. Anyway, naming you have written. Naming you have written. Names you have written. No. You want me to send that also?
Auntie, can you send that also?
Nomenclature also?
Yes, Auntie. I might have missed something because of maybe internet. Just
Okay.
in case. Can you send?
Okay. I have sent it till IUPAC system. So I will send the nomenclature, preparation, and then complete ethers along with in-text example, everything. I have written it neatly. You can just copy that. Finish it off thoroughly. First, thoroughly study the matter given, material given. Then only you will be able to answer extra questions. Don't think that you can learn 1 mark questions like that. No, it's not possible. Unless your concepts are clear, you cannot answer that. So first learn the properly matter given in the book. Whatever I have sent the notes, learn it thoroughly. Then I will discuss all the 1 mark questions. Exemplar, assertion, reasoning, fill in the blanks, everything I will. You will easily answer, Abhik. Easily.
Okay.
You've learned properly the material you have learned.
Okay.
Okay, don't worry. You can definitely answer. P block learn thoroughly. I will show you how much work she has given it and gone now. I'll show you how neatly she has worked for her this, and you just wait. I'll just come. See, I told you, no, she works very well. See her, this one. Can you see?
Yes, Auntie. Reactions.
Reaction. She has written group 16, group 15, group 17, 18. 18, she said, group 17, she has written. Group 18, she said she didn't do.
Auntie, can you send a photo of this, Auntie?
Yeah, I will send a photo of this. See now how she has done all the, this one. Name reactions. Name reactions, name here and back, what is the reaction? She does very good calligraphy. She's very good at it. So she has, see, Stephen reduction, Etard's reaction. If you come home, I can give you all this. Dow's process. Then iodoform reaction. Felling's test. Whatever, all the name reactions, everything she has given. We have not still done Fellings, Stallings and all. We have not done because it comes in aldehydes and ketones. So she has written all that. See, Finkelstein, Wood's reaction, color. She has written everything. See, all the reactions at the back. She has written all the reactions in color. Hoffman's bromamide, amines. We have not still done that. Rosenmund reduction, everything. All the name reactions here. If anybody comes home, I can give you all this.
Okay, Auntie.
Prepare on your own. I'll be very happy. So much she has done. See, Williamson's ether synthesis. She has done. Lieberman's nitroso reaction. What we studied in phenols. Okay, all that. She has written everything neatly. She has worked so hard, and you should see her board. She will write all the reactions and put it on the board. All the properties, everything. She does a really, I actually, my notes, no, I dictated them. last year, because I was taking 2 hours, I had lot of time and no internet issue. They were coming home. So I could dictate it and do it neatly. So I have dictated them. So I took her notes. Because from my notes also I added, deleted, I added extra points and I gave the notes. So I have taken her notes. I am sending her notes only from the next chapter. Okay, she has written everything neatly from, you see her solid state notes, how she has written. And I've done so much extra, everything you will be able to answer. She is saying, I will never lose my chemistry notes. She is saying, I will keep my chemistry notes. I am not giving it to anyone. Like that she has kept. I'll send her solid state notes. So from next class, solid state, I am working out problems along with it. So you keep a rough paper and keep those sheets properly. Neatly you write those, answer everything. Fantastically you will answer solid state. You can write any multiple choice, fill in the blank neatly. That much is not at all given in the textbook. So you will learn it neatly. So I will send a pic of this also. P block she has written. All the reactions she has written. Group 15, 16, 17. 18 only she has not written. You write 18. Okay, you write the 18, this one. Xenon, very important. Xenon, you write the structures, hybridization, compounds and preparation also. Xenon F2, F4, F6. I told you, nickel tube 673, 1 bar, 873, 6 to 7 bar and 575, 60 to 70 bar. How you prepare everything. Learn xenon thoroughly. Definite question you will get. Especially the structures and hybridization. Very, very important. Okay, learn it thoroughly. If you are thorough with the syllabus properly, then you can grow. You will learn on your own. You will learn so much. Okay. So I will send the ethers notes and then I will send the reactions, that notes.
Okay.
And then what else? What all I have to send? I have to send solid state. Solid state. Anyway, problem solutions I were doing that you are writing it out. Write it neatly. All the problems you write it neatly. You can redo it. You will learn. And solid state I will send. Her notes only. I'll just check it up once and then send. Okay. So I'll finish it here today because not everybody is present. I have to start biomolecules, which I want to start when everybody is there. So I'll start in the next class. It's almost time also. So I'll start in the next class. Okay.
Okay.
Sometime I will send the notes. I have little work. I'll finish that and then you guys send the notes.
Okay.
Okay. Bye. Bye.